video we are going to learn how to solve implicit differentiation. Okay, given the question on the board here, we asked to differentiate this question implicitly. You know, differentiation in using implicit function is quite different from general method. Or if you look at this one, is x and y contain, not as the normal one. As we know, the function will be given as y is equals to x squared or any other thing. But in the case of implicit function, once you differentiate y, the function will be 1. Then you can multiply with either dy all over dx, or you can multiply by y prime, or you can multiply by f of x as the function given. Therefore, we are going to learn the implicit function here. Let's say solution. We have x squared y plus y squared plus 4x is equals to 1. Now we are going to differentiate this one using simultaneously using product rule or tail rule. Okay, now since we have x, y, if you differentiate this, there is two ways of differentiating this, either by the use of formula method or by tail rule. Now basically we are going to start learning by tail rule. Okay, in this, if you differentiate x, you are going to keep y constant. Later on you differentiate y and keep x constant. It is either for you to start with y or x. Okay, let's start with x here. If you differentiate x, you are going to have 2xy. Then the next thing to do, now we are going to differentiate y again. That is to say plus. If you differentiate y, you will get 1. Therefore, you can multiply with x squared. And mind you, if once you differentiate y, you are going to multiply also with dy all over dx, or let's multiply with y prime. That is our substitute of dy all over dx. Then we say plus. In the next case here, this is y squared. Then you can say this is equals to 2y multiplied by y prime. Then in the next case, you can say plus. If you differentiate 4x, since this one doesn't contain x, doesn't contain y, you can just differentiate 4x as 4. This is equals to, if you differentiate constant time, here will be 0. Then in the next case, you are going to collect the like term, those that having y prime in one place. Okay, now we can say x squared multiplied by y prime, you have x squared y prime. That is plus 2y y prime. That is to say plus 2xy plus 4 is equals to 0. Then lastly, you are going to collect the like terms. We can make y prime as the factor. Let's factorize this. Since we have y prime, we have y prime here. Let's factorize y prime is equals to y prime, we open brackets, we put x squared plus 2y plus the brackets. We say we can take this one to the right hand side by saying this is equals to minus 2xy minus 4. Okay, now since y prime is same as dy all over dx, then we can also replace y prime as dy all over dx, or let's divide both sides by the coefficient of y prime here. Divide both sides by x squared plus 2y. X squared plus 2y. Therefore, this one they cancel out here. We have y prime is same as dy all over dx. This is equals to, since this one goes, remain minus 2xy minus 4 all over x squared plus 2y. Then that is the end of the using theorem. Don't forget to like, share and subscribe our channel. And we are going to use the formula now. Let's use the formula method. By the use of formula, it says if you have dy all over dx, when given the function like this, then you can use formula and says this is equals to the function minus f subscript x all over f subscript y. Therefore, in this case, we are going to differentiate any function contain x for the numerator. Later on, you can differentiate any function contain y in the denominator. Okay, let's see how we can. Since we says we have dy all over dx is equals to y subscript x, that is minus all over f subscript y. This is equals to any function contain x we are going to differentiate here. That is, here we can have 2xy. That is to say, here we have, this one doesn't contain x. We say we have plus. If we differentiate this one is contain x, we'll have 4. Then all over. Then the next case, we are going to take the function containing y. Yeah. Since this one contains y, therefore we are going to have, in this case, we are going to have only x squared. If you differentiate y, this shows that it's multiplied by 1. Y will be 1. If you multiply y with 1, it will remain as the constant. It will remain this one as x squared. That is to say, this is plus. Then this one is 2y squared. If you differentiate this, you will have 2y. Then lastly, you have to multiply the numerator with minus here. If you have dy all over dx is equals to, then you multiply minus with the numerator. You have minus times 2xy, you have minus 2xy, minus times plus, here you have minus 4 all over. Here it doesn't have any the minus, then you can put x squared plus 2y. That is as simple as this. Unlike using the theorem, I think this one is very simple to do when solving implicit function. Thanks for the watching. Don't forget to like, share and subscribe. Bye.